All right, today we're diving deep, microscopically deep, into the world of silicon. We're on the hunt for something that sounds like it's straight out of a movie. Silicon's invisible ninjas.
Okay, look at this number. 10 to the 11th power. What is that? That's 100 billion. And that's the estimated number of invisible, nanoscale glitches hiding inside a tiny piece of silicon, about the size of a sugar cube. And here's the twist. These aren't just random mistakes. They're actually a crucial but super mysterious part of what makes our modern tech even possible. I mean, think about it. Silicon is literally everywhere. It's the heart of the entire gigascale device industry. Your phone, your computer, it's the key to photovoltaics, solar panels. But here's the thing. This idea we have of a perfect, flawless, pure silicon crystal, well, that's kind of a myth. The reality is, it's full of defects, and as it turns out, that's not always a bad thing.
So if these defects aren't always the enemy, then what's the deal? Well, sometimes they are actually silicon's secret allies. Yeah, you heard that right. Scientists have figured out how to use certain imperfections as little helpers in the chip-making process. Let's dig into how they do that.
So what we're talking about is a lattice defect. It's just a little hiccup, an interruption in that perfect repeating grid of atoms inside a crystal. Now get this, in silicon manufacturing, engineers intentionally manage some of these, specifically oxygen-related defects. It's a process called impurity gettering. You can think of it like setting microscopic traps. These defects are great at attracting and grabbing unwanted junk, cleaning up the silicon so the final chip works way better.
Okay, so how do you even find these tiny little helpers? Well, for most defects, the method is surprisingly visual. See, they cause stress or strain on the atoms around them. And when you look at them under a powerful microscope, these strained areas just pop. As one paper so beautifully put it, they light up like stars in the night sky. It's an amazing trick. But you knew there was a but coming, right?
And that catch? Well, it's a big one. This brings us to the invisible ninja problem. The whole issue is that some of the most critical defects, the ones that actually kickstart this entire purification process, are completely invisible to the usual methods. They cause no strain at all, so they don't light up. They are, for all intents and purposes, the ninjas of the silicon world.
So let's just break this down. On one side, you have your strained defects. They're the easy ones. They warp the crystal a little bit, they light up under the microscope, piece of cake. But on the other side, you have these unstrained defects, and they're just a single, super thin layer of oxygen atoms that fit so perfectly into the silicon grid that it creates zero stress. It's completely hidden. They're so sneaky, scientists gave them this awesome nickname, ninja plates. And what they do next, it's a wild story of transformation.
And this is where the story gets really, really weird. These ninja plates don't just stay invisible forever. Nope. They go through this bizarre life cycle where they actually change shape and reveal themselves in a process that scientists are really just starting to get their heads around.
Here's the three-stage model of how it works. First, these ninja plates form as a single, unstrained, totally invisible layer. Then, and we don't totally know why, they suddenly collapse and morph into these tiny 3D strange shapes. And scientists literally call this moment decloaking. How cool is that? Now they're visible. Finally, as they keep grabbing more oxygen atoms and grow, they change shape again, flattening back out into a larger platelet that's still strained and visible.
And what's just wild is that even the experts are scratching their heads about parts of this. See, a silicon crystal has these preferred directions, or planes, for building things. The fact that these platelets form where they do, it basically goes against the grain. As the research paper admits, it's a total mystery. We're really watching a nano-detective story play out in real time.
Which, of course, brings us to the absolute core of the challenge. I mean, if the most important first step of this whole process is carried out by something that's totally invisible, how on earth do you study it? How do you find the ninjas before they decide to decloak? Answering that question is a monumental task. This is all about the mind-boggling scale of this challenge. We're talking about the 100 billion defect hunt. This isn't about finding a needle in a haystack, it's about finding billions of invisible needles.
Let's just look at that number one more time. 10 to the 11th power per cubic centimeter. 100 billion defects. Trying to find them is like trying to find 100 billion specific invisible needles in a haystack that's the size of a sugar cube. That's the staggering scale of this scientific hunt.
So, why bother? Why go through all this trouble? Because cracking this mystery could have a massive payoff. For the chip industry, it means much better quality control. For solar panels, it could mean a huge jump in efficiency. And for science itself, it's about solving a really fundamental puzzle of how the tiniest arrangement of atoms can completely change how a material works. And just when you think it couldn't get any harder, there's another roadblock. The simple act of preparing a sample to look at under the microscope can totally ruin the experiment. Just exposing a freshly cut piece of silicon to the air for a moment can cause oxygen to stick to the surface, creating a whole new layer of mess that hides the very ninjas you were trying to find in the first place. So, solving these challenges, the invisibility, the insane numbers, that risk of contamination, that's the final frontier here. This quest isn't just for curiosity's sake. It is the key to unlocking better technology for every single one of us.
You know, one of the coolest things about the research this explainer is based on is that it's not pretending to have all the answers. It's the opposite. The paper is basically a call to arms, an open invitation for scientists to bring new ideas and new techniques to the table to finally shine a light on these invisible ninjas. It's science at its best, a collaborative, ongoing mission.
In the end, we've seen how a single, invisible layer of atoms can completely change the quality of the very material that powers our entire modern world. It really makes you stop and think, doesn't it? What other incredible secrets are hiding in plain sight in the fundamental materials that we use and touch every single day?